Okay, now the next one, school survey finds that 4/5 of the students like pasta. 3 students are chosen at random. What's the probability that all 3 like pasta? So this is finding the probability that 3 kids like pasta. Okay, so 3 like pasta. Well, they all are the same. The probability that they all like it, one kid liking it is 4/5, a second kid liking it is 4/5, a third kid liking it is 4/5. Okay, so that's just 125 over 64. Okay. All right. Millie is playing cricket, a game of hockey, and a game of hockey on the weekend. The probability that her team will win cricket is 0.75. So probability of winning at cricket, 0.75. Cricket equals 0.75. All right. Probability of winning at hockey, win hockey, is 0.85. Okay, and the question is, what's the probability that Millie's team loses both matches? All right, so we want to find what's the probability of we lose both. So you're going to lose at cricket and lose at hockey. So that's an and, so we're multiplying those two probabilities. Now, you're not multiplying those, actually, you're multiplying the complements. Okay, so the probability of losing would be, let's see, let's do it like this. Okay, probability of losing is 1 minus 0.75 times, and the probability of losing hockey is 1 minus 0.85. The complements. Okay, so multiply those two guys. Minus 0.75, 1 minus 0.85. Okay, and then there's my probability. Okay. All right, 3 events are such that A and B are mutually exclusive. Okay, now, as soon as you see this, mutually exclusive, okay, from that, you know the following. If something's mutually exclusive, then if we do A union B, then that's going to equal probability of A plus the probability of B. There is no overlap. Normally we subtract the overlap. There is none. Okay. All right. Now it's asking you, so what you're going to do is plug in what we know here. So let's see. We know the union is 0.4. Okay. So this is 0.4. We know P of A is 0.2. And we want to find P of B. Minus those two. P of B. Okay, so that's P B equals 0.2. All right, and then it says find the intersection of B and C. Okay, so let's see, that's that. Okay, P, B intersects C. Oh, excuse me, that's union, not intersection. Sorry. Oh, I'm sorry. No, that is an intersection. Okay. All right, so you know this. The probability of B union C is equal to probability of B plus the probability of C minus their intersection. So you just plug in the numbers. Let's see. This is 0.34. Okay, this is 0.2. And this is 3. So they'll solve for that. So 0.3, 4.5. B is going to be negative 0.16. So it equals 0.16. Okay. All right. Determine if B and C are independent. So if you look at it here, the one with the nice handwriting, and turn it over to the back. If you want to find if two are independent, then you can use any one of these tests. So what we're going to do is we're going to see is this true for this. We're going to use this test right here. Okay. All right. So to determine if B and C are independent, we're going to ask ourselves this: does the probability of B intersects C, does it equal the probability times the probability? Does this hold? So when we plug, are they equal? And if they are, then they're independent. So I'm using this rule. Okay, let's see. We got this is okay. This is 0.2 and was 3. So we can see it doesn't hold true. B and C are not independent. Okay. Okay, did I leave out some problems? Let's see, it goes 1, 2, 9. Looks like I left out 5 and 6. Oh. Okay. So let's see. You're given that element of E and P of F. Okay. The intersection. Okay. So if P is equal to 0.6, then the probability of E is 0.4. Any questions on that? You got to add up to. And if this is F complement, okay, so that's P right here. All right, explain how you know that independent. Okay, so this is B. Okay, so we're going to first test for, and so we're going to ask ourselves, does the intersection of E and F equal the probability of E times the probability of F? Does this hold true? Okay, so when you plug in the numbers, 0.24, and let's see, P of E was 0.4, and P of F was 0.6. Okay, so the way you know that this is equal is this statement right here. Holds true. Okay, how do you know they're not mutually exclusive? Because they intersect. Because they have, the intersection's got a probability. Okay, and now C, find the union. Okay, so E union F. Okay. Okay, so we're going to use our addition rule, guys, right here. Okay, and we know they're not mutually exclusive because of the last statement here. Okay, so we're going to do that. Okay, that's your addition rule. So use P E union F equals, that's F prime now. Okay, so that's P E plus P F prime minus the intersection of those two. That's kind of hard to read. That's the intersection. Okay, so let's see. P of E, 0.4, plus P of not F, 0.4, minus, okay, now we got to find the intersection of those two. Okay, so how do you get the intersection of those two? Pardon me? I'm sorry. Let's see. We found P intersection F, but this is P intersection not F. See, we have it there. And that's intersection F. And we want P intersection not F. How do we find? Okay, why add? Add these two together? Okay, so let's take a look at a drawing here so everyone can see why that is. This is E, this is F, and what this one's asking us for is the intersection of E. So here's E. So this is, we're looking for the overlap of these two. So not F and E would be that. Okay? Remember, this is the same as only E. Okay? So we know, guys, we know that the intersection of these part is 0.24. E altogether, the whole thing is 0.4. Okay, so to get this intersection, you just subtract those two. Questions on this? So I'm going to do this, take away 0.24, which is 0.16. Okay, so 0.8 minus 0.16. 0.64. Let's see. Yep. Questions on how we did that? Okay. All right, number 9. A and B are independent. Okay. Oh, number 8. Okay, a 6-sided die is numbered. It's thrown 3 times. What's the probability the scores add up to 6? Okay, so you got to make yourself a sample space. How many different ways can you get 3 numbers that add up to 8? Okay, how many, if you threw this 3 times, what combination of numbers is going to give you 8? So we're looking for outcomes where the sum of the first throw plus the second throw plus the third throw is equal to 8. That's the outcome that we want. Pardon me? Oh, it's a 6. Okay. Okay, what's the probability that they add up to 6? And you only have a 1, a 2, a 5, and a 6. So think of a combination of 3 throws that would give you 6. So like a 1, 2, 2. Okay, that's 5. A 1, 2, 5. Too big. A 1, 2, 6. Too big. Okay, a 2, 2, 5. Too big. A 2, 2, 6. Too big. Well, you could get a 2 on the first, a 2 on the second, and a 2 on the third. So this would be the same as the probability of a 2, a 2, and a 2. Okay, and the probability of getting a 2, if it's got 6 sides, is, let's see, what's our probability? Because there's 2 of them, right? Yep, so that's 2 out of 6. So this would be 2 out of 6 times 2 out of 6 times 2 out of 6. So that's going to be 8 over 36 times 6, 216, which which is 1 over 27. All right, and the last one. All right, let's see. They're independent. Okay, so if they're independent, we know this. Their intersection is equal to their product, PA times PB. Okay, so this first one, A intersect B, is going to be 0.9 times 0.3. Okay, B. Okay, the probability of this is only A. So if we took a little graph here and looked at it, let's see, A, B, and we know that the intersection is 0.27, and we want to figure out this guy. Okay, that's only A. Okay. So we could take the probability of A, which we know, and take away the intersection. Okay, and then the last one, A union not B. Okay, so that's a union, guys, so we can use our rule here. Right there. So PA plus PB, or not B, minus their intersection. So that is 0.9 plus, okay, if this is 0.3, then this is 0.7, because it's not B, and we did, this would be 0.63. 0.9 plus 0.7 minus 0.63.